Do you know when to use the object-oriented programming as compared to its procedure-oriented programming counterpart? Do you feel mental tussle in relating any real-world object with its object code? Do you know how many fundamental object-oriented concepts coexist in object-oriented programming? Do you want to know various Python object-oriented terminologies through Python code example? Stay tuned till the end of the episode to know all the answers.
Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about real-life class and objects. We will introduce you to the concept from where the object-oriented programming concept originated. Next, we will discuss when the object-oriented programming should be used instead of procedure-oriented language. We will talk about multiple scenarios. Next, we will give a brief idea of the mental tussle that each and every student like you face when they try to understand the object-oriented programming. Every time you will face and will give you a fair idea how to deal with this mental tussle. Next, we will discuss object-oriented concepts like class and object. Going further, we will talk about method, encapsulation, inheritance, abstraction, polymorphism. Now, these two are the basic concepts, and these are the concepts that coexist in object-oriented programming. Also, we will give you code example of each and every concept. Next, we will go through code example of all the object-oriented concepts in Python 3. Going further, we will do a comparative study of Python object versus module. And finally, we will summarize our entire learning of object-oriented programming in Python. So this is the menu for today. Without any further delay, let's begin. Real-life class and objects. So here I will give you a pictorial example of real life class and object. So here you can see multiple students are sitting in a class, right? And here you can see there is a teacher. Although the teacher is blurred, but you can see her still. Now you can see that there are many students. So here are some students, here are some students, and these are the students who are backbenchers. Now this is a very typical example of class and object. When you are in a school, right, you are in a class, and that class, each student will have a name, a roll number, and you might have a section of your class, and each of the student will have different names. So these are the objects, and here the teacher also belongs to the school. However, he or she may be a different object, or rather a different class. Now, teacher is also a person who is inside the school, but the criteria of a teacher is very different. So here the teacher, obviously his or her age will be very much higher than the average students of a class, and this is the difference of the teacher and the student class. Obviously, if you go to a teacher's room in a school or college, all the teachers will be there, so they belong to the same particular class, means not the school class or school standard, but the class in terms of the concept of object-oriented world. Now teachers are teachers, and they are human beings, and they belong to the school. The students are also human beings, and they belong to the school. However, teachers are a separate class and the students are of a separate class. The property or criteria of students and the teacher makes them different, and this is the real life concept of class and object. And the teacher, if I say teacher, this teacher may have a name which is given by her parents, and she is carrying that. And in the teacher's room, when you go there, there may be 30-40 teachers. Each of them will have a different name, different age, and they will teach different subjects. So even if you look inside the class of teachers, each teacher will have different properties. And here, if you look, right, visually all the students are different. So you can see some of are them girls, right? Some of them are boys, you can see, and some may be a bit taller here, okay, and some of them may be a shorter of height. So there are different properties each of them are carrying, but they belong to the same classification. Rather, if we shorten the word classification, it becomes class. And here the student class has all the students. However, each of the student who are the objects of that particular classification or class has different properties. So here some of the students may have black hair and some of them may have brown hair. Some of them are wearing t-shirt while some of them are wearing kurtis, some of them are wearing t-shirts, and here you can see the student is wearing a shirt. This way each object is different from one another. However, you will see such visual difference if you go to the teacher's room. Each of the teacher will be either male or female, and they will be of different heights, they will be wearing different clothes, they will teach different subjects, and they will have different degrees, although they will have a common classification of teacher. So that classification or the class of teachers is a set of people who are having some properties similar. Again, similarly, all these students have some of the properties which are in common, so they belong to the same classification or class, and each of the student is an object. Similarly, each of the teacher are object of the class teacher, and here the students are the objects of the class or classification student. So here we have given example of real world class and objects which you can find in vicinity of you. And today if you are learning Python, you might have already passed several standards to reach up to this level, and you have seen this. So this is not something, the concept you have to virtually draw or hypothetically draw. It is there in front of your eyes. So you can start thinking about the class and objects with this particular and very easy to grasp concept. We are done here. Let's move on to the next slide. After having the concept, now we will discuss when to use the object-oriented programming instead of procedure-oriented programming. So here, let's start the first point. The system being designed is large or likely to become large over time. So you can see if I compare this line with the picture just I have shown, right? So when a school starts, right, it may have from standard 1 to standard 5. Then as the school grows, more 5 standards are added. So it now have, after maybe some years, it has standard 1 to standard 10, and then it will have 10 plus 2. So this way it will grow. And also each of the class can grow in terms of the sections. Say we have a class, say it is standard 1. When it started, it only has 2 sections. Over time, when the population increase inside the school, right, in the next or coming academic years, so there could be section A, section B, and section C. So this can become larger. So when we are having the concept of the object-oriented programming, we have just shown, right, in the last slide. So this way we will keep on relating the concept to the programming concept, and the object-oriented programming is applied on real-world objects which can grow over time. That means the objects class will be the same, but the number of objects can grow over time. So this is what we are talking here. The data can be put into obvious structures. In the previous pictorial example, you can see that we can put the teachers into the classification of teachers and the students in the classification of students. And we can then subdivide as per of their hairs, variables, and etc. etc. So obvious structural shape should be there of the data to apply the object-oriented programming. There is prominent of inheritance and polymorphism. We will talk about the polymorphism and inheritance in detail in later and chapter and slides. But just to brief, inheritance is nothing but what you get the properties from your parents. That means whatever criteria or whatever qualities you have inherited from your parents is called the inheritance. And polymorphism is a different concept. To explain this, we will have to wait till the slide of the polymorphism. There is a piece of data on which many different operations can be applied. If I say there is a class test, so there is a method, right? So that class test we can apply on each of the students. So a class test is announced on maybe 15th of say January, and that 15th of January, each and every student will have to face a class test. So a piece of data which maybe many different operations can be applied. So one is a class test, and maybe on the 30th of January, there there could be one sports event. So these are different events and operations. They can be applied on the objects. And here we say there is a piece of data. Here we say this piece of data is nothing but the clan of students in the school. You may need to perform the same general operations on related types of data, but with slight variations depending on the specific type of data operations are applied to. So again, let me bring the previous here. There is a class, and there the class test is going on. Okay. Slight variation is what? Say student 1 may require 5 extra pages for writing the test, and student 2 may require 10 extra or 15 extra or 20 extra sheets for their exam. So there is slight difference in between them. Once the result come out, right, of the class test, there will be also a difference of the result of numbers. So here you can see there is a variation, but however there is a generality among the students. That is the classification or the class, and each of the students, when they are addressed, they are called the object. Chances are there that you may add new data types later. So you can add something, some addition is there, right? So this might happen. So such a way the object can have some addition of the data, and you can see as the student grows, there could be some other changes as per the rules of the school. The implementation of individual components of the system is likely to change over the time. So something which we can expect to change over time, the object-oriented programming can accommodate that. So that accommodatability or accountability should be there inside the object-oriented programming. The system design is already object-oriented. Large number of programmers from multi-site will be using your code modules. Here we are talking about the specifically the industry which you are working, or maybe you will be working. That is the VLSI industry. If you are designing a system, that is a chip or something like that, that should be always object oriented, because there should be multiple variants of the chip. One may be high frequency operation, one might be power saving operation, and one might be RF application. So different variation of the chip could be there. VLSI industry, when you are doing something, it should be always object oriented, and large number of programmers from the multi-site, they will be operating. This is because today any of the VLSI company is operating like a MNC, and maybe you are sitting here coding from your cubicle which is in India. Someone in your team may be sitting at Seattle, someone may be sitting at Zurich. So this way the multi-site operation happens in today's VLSI scenario. When multiple people access the same set of data, it is better it is object oriented. If it is procedure oriented, it should have to be looked from the 0th line of the code and they have to understand everything. But in object oriented programming, since they are dealing with one particular object, they need to get aware of the class and the details of the class, and accordingly they can do modification whenever it is necessary. So we are done here discussing all these points. So let's move on to the next slide. Object-oriented concepts. In this slide, we will have multiple object-oriented concepts at a glance so that you can have this snapshot with you in your mind. So here are the different concepts. So class we have talked about, object we have talked about, we have to yet talk about all other. And remember, in object-oriented programming, all the concept, that means the class, object, abstraction, encapsulation, inheritance, polymorphism, they exist all together. That means they coexist. In case of you, when you are going through this episode, you have to learn them sequentially. However, you have to keep all of these concepts in your mind alive at any instance of time when you are writing or modifying an object-oriented code. All these concepts should be very clear. And now we are doing this episode for Python 3. So whatever you are learning in this episode, all the concept examples that should be ready. That means conceptually they should be ready in your mind whenever you are doing a Python 3 object-oriented programming. We will talk about the abstraction, encapsulation, inheritance, polymorphism one by one. Also, we will talk in detail about the class and object in upcoming slides. Here we have given one slide where we have given a snapshot of all the concepts those are necessary for object-oriented programming. And I must emphasize that all of these concepts concept coexist. That means we cannot have any concept individually outside the object-oriented programming. All are inside the object-oriented programming. Here you can see the entire the black oval, right? That is the object-oriented programming, and all the concepts are coexisting inside that particular oval. You should be very much easy with all of these concepts before you start coding for the object-oriented programming. Here we are done discussing about these coexistent concepts, and let's move on to the next slide. Mental tussle of understanding object-oriented programming. I have kept this particular slide so that you can have a fair idea what type of tussle you are going to face in the upcoming sections. Let us get familiar with the mental tussle, and also I will give some tips so that you can overcome the mental tussle. So this is the world where we code in the object-oriented programming, like maybe C++, maybe Java. So there are a lot of object-oriented programming, right? And here we are having our object-oriented concept. So the tussle is to switch between these one concept to another and back to this concept. This is very tough. Although when I discussed using this picture a few slides back, it seems very easy, right? But however, when you are going to code, you will see that switching between the code and the concept is a bit hard at the beginning when you are at the learning level. Later, as you become familiar and get easy with the object-oriented codes, this will go away. However, here I assume that you are learning the object-oriented programming at the first time. So I have kept this slide that this is the mental tussle you have to face, and it's okay you are facing this. There's nothing awkward in facing this kind of tussle, and you should not blame yourself that you are not capable of learning object-oriented programming. So this is the mental tussle you are going to face until you get easy with the object-oriented coding. So this is true for any of the programming language which is object-oriented. Right now we are talking about Python. In case you go ahead learn Java, you might also face the mental tussle will be here everywhere, and it becomes easy after certain time. You have to give some time to elapse and you have to keep on learning, and at some point of time you will be easy so that you can switch from code to the concept and concept to the code. So the switching will be faster for you, but for that you have to get familiar. You cannot be very faster switching in between the concept at the very beginning, right? At this moment when you are here in this slide, you will not have a very faster speed of switching between the code and the concept. You will get slowly familiar with the terms and coexistent concepts, and then you will be very easy. Once you learn all of them, you practice one or two codes. Obviously in this video I am providing all the code download links so you can try it at your end, do some modification and see what it's the outcome. You will have the code download links in the GitHub in the description, and once you click on the link you will go to GitHub. From there you can download them. Now I think your mind is very much clear and you will going to have this kind of tussle, but the tussle is nothing that you should be afraid of. And let's move on to the next slide. Now, straightly we are coming to the definition of class. What is a class? Before popping up any point, let me say the class came from the classification, and classification means we are categorizing some of them, whichever it may be people, it may be animals, some of them with the similar kind of property, and the classification you know, and from there the word class is coined. So what is a class? Introduced first, the concept of a class lays the foundation for object-oriented programming. So it is the foundation, the class or the classification, right? It's the foundation of the object-oriented. A class is the blueprint or template that defines the attributes and behaviors common to all of the objects. So this is a kind of, say, blueprint, or you can say generic structure of the objects. So here all will be generic, and when we are instantiating objects, they will be having the specific type of data as per their own individuality. But the class will have a generic definition which is called the blueprint or the template, you can say, and it will have the attribute. Attribute is here mentioned as generic, and the attribute becomes specific for each of the objects. It serves as a design for creating object. You can say it's a prototype. So from there you can create multiple objects. It defines a data structure that encapsulates data attributes, that is the attributes, and the function which are called methods. So now we are going further specific here when we are talking about the class is a data structure. data structure, now we started talking about the programming concept, and now you are having the switching between the two concepts, right? This line starts your switching in between the real world picture and the code, which I have just shown you in previous slide. So here the data structure, it encapsulates. Encapsulation we also talk about. What it encapsulates? The data, the attributes. Data means the specifications and the function method. So these are the working method, and sometimes these are, in some programming language they are called function, in some programming language these are called subroutines, whatever it is. But this is the way the object is classified. That means the class is defined. In simpler terms, a class serves as the prototype for creating objects with similar characteristics and behavior. Objects with similar characteristics and behaviors. That means whoever the students of class 1 or standard 1, they will almost be having the same kind of properties. Their age, their mental capability, all these things. So this is very easy to grasp. And the next point is, object created from a class share the same structure and behavior but may have different values on specific attributes. When I have shown you the picture of the students in the class, I have pointed out there that each student is wearing different clothes and their hairs are different. Some have long hair, some have short hair, some have brown hair, some have black hair. So like that, even their eye color could be different. It may be blue, it may be black, it may be brown. So now let us see a code snippet of the class in Python 3. How to write a class? Say we are writing a class of dog. Now dog is the real world dog that barks, okay? And we are defining with the class keyword. You can see the keyword is in green. So we have code highlighted here. So the next one is the def init. You can see the def is a keyword, and then we have, I think, double underscore here, then init followed by double underscore, and then we write another keyword self, and then we write name and age. So self is there, it is also a keyword, you cannot change it. Name and age could be changed. Name and age are attributes. Self is for creating the object. Now self.name, that means the name of the object should be the name. So self.name, dot is a hierarchy separator here in the object oriented programming. When we are instantiating the object, this self will be replaced by the name of the class. Or this is a class, this is a generic name, it will be replaced by the specific name of the dog. So self.name, and that generic name here, the dog.name, will be feeded with the specific name. So this is the way the code is done. We have the self.age is age. So we have the object dot its attribute, and we have the proper attribute value. So name and age are attributes here, but here they will contain values. So it will contain string and it will contain numbers. This way you can write the class in object oriented programming in Python 3. So let us move on to the next slide. What is an object? Once the concept of class is established, objects may come into play. So we have just defined the class in the last slide. Now we can go ahead for the object. An object is an instance of a class representing a specific occurrence or realization of that particular class. Object encapsulate data and behaviors defined in the class. Encapsulation we will come later, and you can see the behaviors. That means the different variation of the attributes, those are captured. An object-oriented programming is a self-contained unit that combines data, that is attributes, and the functions that operate on that data. So it will have data, and the function or methods, they will operate on the data. Why this encapsulation? Because you cannot access that data from outside without the methods. You cannot get any encapsulated data from outside. How? Let us give me an example. You want to know a particular name and the roll number, the class, the section of a particular student. How you can get that? For that you have to enter into the school, go into the class, talk to the teachers. Without that you cannot get that data. So this is called encapsulations. From outside of the school boundary you cannot get that data. So this is called the encapsulation. That means the protection of the data. Only if you follow some rules and follow some methods to get that data, you will get that data. Otherwise you will not, from outside of the environment, you cannot get that data. This way the data is either accessed by the methods, that means in the read operation they can be read, or write operation, so they can also change the data. So student has a pocket money. Every day they come to school, right? A parent come to the school, say that he or she has mistaken to give the pocket money and gives that pocket money to the student. So this way they are modifying the pocket money attribute, right? After the student has reached the school, the guardian has come to the school gate and asking that whether that student has pocket money. The student comes and responds whether he or she has received the pocket money so that she can or he can go back from the school using the bus or the transport. Objects are instances of classes in object-oriented programming. Instance is nothing but when we have a generic definition and we instantiate it on a specific, right? In a class, we have a student called John and we have Ram. So John and Ram are the two specific instances of that object called student or the class called student. It's not the object. Object is John and Ram and the class is student. Each object has a specific type defined by its class and can interact with other objects. Here another thing, the interaction, there should be a defined method. Without the defined method, they cannot interact. Objects are used to model real-world entities or abstract concept in a program, providing the way to structure a code, promote reusability, and encapsulate related functionality and data. So we have talked about this concept quite far enough and we are going forward and you will now plunge into the code and you will see how the code is doing all of these things. And as I said that you will having the mental tussle to correlate the real world concept and the lines of code. It will be there inside you and don't think that it will not be there. So it will be there. It will exist until or unless you become proficient in doing the object oriented code. So at this point, if it is okay, if you are facing this mental tussle, it should exist. For some of you, it will exist in a more quantity and some of you, it will exist in a lesser quantity. Okay, let's move on to the next point. In simpler terms, an object is a tangible instance of a class, representing a specific entity or concept in the software. This is a very line that defines the code. Let us see the code. Now, remember we have defined a class dog in previous slide. Now let us create the object of that dog class. Now we have created a instance. So here the instance name is my dog. It's a data type, okay, where we are doing the encapsulation of the input data, where the name is Rambo and age is 3. So this is the class. So when we do this, right, the self keyword, which is inbuilt, transforms all of this given data into an object and store the data structure in my dog as an object. So once this encapsulation is done, you cannot read the data of Rambo or 3 from outside without having a proper method defined inside the dog to read this data from outside. This is the thing which is called encapsulate. Obviously, we may have some stricter version of the encapsulation. I am not going to that point. Rather than we are talking in a very simple terms up to this point, and we will go more complex as we move forward. And say you are inside the object-oriented programming environment. Each year or maybe each month, you will attain a different level of complexity because the object-oriented concept is a concept can deal with a large complexity, but there should be a structural form of the complexity. Here we are done with this particular slide. Let's move on to the next slide. What is a method? As we have seen that methods are some tools to either transfer data from outside to the inside or from inside to the outside. Generally, this is the methods. So there could be other methods too. And those methods could be specific to a particular classification or class that you are writing and based on the objects which are required by the later part of the program. In the object-oriented programming, method is like a special set of instruction or rules that belongs to a thing that is an object. And we define these set of instruction in the class definition and we use them when we instantiate them as an object. It is a way to describe that thing we can do and how it behaves. How it means how the object behaves. In various programming languages, subroutine or functions inside a class or object are called methods. However, the methods or the rules may not be limited to subroutine or functions. They can go in case of any future development of the object-oriented concept in any of the shape or forms where these are rules or they are kind of methods which can deal or process the data. So up to now, when we are talking, these can be broadly said as functions or subroutines in a programming language. language. And let us move on to the next point. Methods help organize actions related to objects, and they are like unique skills or abilities that an object has in a program. Now we have done talking theoretically about the method. Now let us see a small code snippet of the method. Let us define it. We are using the keyword def to define park, and then we are giving self. So you can see the argument that is going to the function or the subroutine here is self, and the name here is the park. And what we have the print statements. So self dot name says woof. Woof is something a dog says when it barks. So this is one method we are defining. It's a simple thing. Let us learn the simple things first, and then slowly you can go for the complex ones. This is what is called a method and how we define a method. Now let us move on to the next slide. Class and object example. So here we will contain our code. Start the code with hash bang user bin python 3. This is our Python interpreter. Next we have class dog. We write the class which we have shown you a couple of slides back. And here inside that we have the def init. Then we have self, name, age. And then we have the self dot name. That means the attribute of name is getting the numerical value of the name. And here self dot age is the age. So here it is a simple variable, but here it is becoming an attribute. So self dot age, self dot name, these are now attributes of this particular class. Now let us define the method def bark then self, and we write the self dot name says woof, creating an object of the dog class. My underscore dog, then we give the dog class, and then we give the name Rambo and age 3. Now you can see this passes to this and this passes to this, and here they are made attribute and the value is going here. Similarly here the value is going here to this attribute. This is happening automatically. Accessing attributes and calling the methods. So we print my dog name is my dog dot name. So this is what I told, that whenever we put the dot, which is a separator, hierarchy separator, dot then name, this will access this value. Now self dot name is my dog dot name. So my dog is the object and object dot name. So we are having the object's name attribute printed here. Now it is no longer the simple name object. It has become the object's attribute. Now my dog dot bark. So we are calling the method. Once we execute this particular code in the terminal, this is happening. My dog's name is Rambo and Rambo says woof. First command, this one is saying that my dog's name is Rambo, and here this is giving Rambo says woof. When this is called, the control goes back to here and this print statement is executed. So that is the very short and sweet example of class and object and the method. It's a very simple thing and it is highly relatable to the real world. Now let us move on to the next slide. Creating a class in Python, another example. Here in this particular code, we will create the code of a student who belongs to a particular class. Let us see. Here goes our code. First line is our Python interpreter. Next one is we are writing class, then we are writing student. So here we are writing the class student. The self word is the object constructor, right? And here we are writing the def, then double underscore, then init, then double underscore, self, then name, surname, then roll number. So each student will have these things. And then we make it as an attribute. So self dot name, this is becoming attribute, and here we are storing the numerical value of the name. Next we have the self dot surname, and we store the alphanumerical value, whatever it is there for the surname. And here we are writing the self dot role, the attribute, and here we are storing the numerical value of the role. So here it could be alphanumeric, or maybe a character, or maybe alphanumeric, or maybe character. This could be numeric, and they can be stored in the attribute. So this is where we are linking the attributes to the real world inside the class. This is the definition. Later everything is automatic, and once we declare it will automatic, all these things will happen. So here we define once and we use it multiple times. Method 1, definition, set name, self date name, and what we do, self dot name is name. Again we have to change the name. We can use this. Next, return 1, and method 2. Return was in nothing but it returns 1. We have a corresponding return value. Next we have the method 2. This is method 2, and we have def, then set surname, then we have the constructor self, and then we have surname. and here we have set then surname. In case we have to change the surname, so there could be some text mistakes in writing the name or surname. So these methods are there in real time to modify them, and we return 1. Next, we continue the code here. We write method 3 def set roll number self.roll and roll number. So there could be mistake in writing the roll number, and we can modify it using this particular method, and we return 1. Method 4 def display self. So display means it will display all the details, say name, surname, roll number. And what we have body, we have print name equal to self.name, print surname equal to self.surname, print roll is self.roll. This will display it. So you can see this is the beauty of the encapsulation. From outside you cannot directly access the surname or something. You have to use a method either to store the data. That means here we have 3 ways of storing the data, 1, 2, 3, and here we define that time we are storing the initial data, and here we can modify, or we can print the data. Either input or output of the data we have to go through defined methods. So 4 methods are declared here. And object destructor is here. Destructor del, it is double underscore, then del double underscore, then self. Destructor is used for the memory optimization of the computer in which you are running the object oriented code. And destructor actually helps that whenever the usage of that particular object is finished, it clears all the memory. So memory is what? Some memory will be kept for all these, right? For that particular object, and all these memories will be cleared out by this object destructor. Don't think that object destructor is at last means that whatever we have written is going to destroy after this line. No, it's not that. When a real-time object is used and there is no longer use of a real-time object, the destructor will destroy the memory and the memory containing the data. Now here we have the print destroy is called from student.py. We are going to save this particular file as student.py. So I have named it here. Okay. When you are downloading this code from the description, you will also find that the student.py is there. So we are done here creating a class in Python for the very well-known concept of the student. Now let us move on to the next slide. We are done here. Creating an object of a class in Python. Now here we will create an object. So first here the code goes. Here we start here with the Python interpreter, and here we write if namespace is main. Now we are creating an object of the student class which we have defined in the previous slide. Student object is student, then we are writing the name Naga, then surname is Yamini, and we have roll number 112. Displaying the initial details, we say student obj then display. Modifying the details, how we can modify the details. We write the object name, right? Student.object, then we give the method set name, then Ram. So we are changing it. Next, we are using the set surname method, set surname Prasad, and we say set roll is 112. We are changing the name. The name was written by mistake, so we are changing it. And here displaying the modified details. So here we will say student obj.display. So earlier one display method was called, and here another second time it is called. So first time it should give this data, and second time it should give this data. Once we execute the code, this comes. So name is Naga, then surname is Yamini, and roll number is 112. And in the next call of this display, we get name is equal to Ram, it is changed. Surname is Prasad, it is also changed, and roll number is unchanged, 112. And once this object is used and there is no longer use of the object in the entire code, so the destructor is called. Destroy is called from student.py. So this is also a concept you should be familiar. You can use a destructor or not. It's up to you whether you are using a destructor or not. But in case you are using a destructor, right? In case there is a troubleshooting, you will get a print message at some point and you know that object has been destroyed. Based on the need, you can either use the destructor or you may not use the destructor. And you may have a message, you may not have a message. That is up to you. So it's up to you how you deal and how you do the code. Example is given to you. You can download this example from the link provided in the description, and from there you can go ahead and readily execute this code. You want to do some modification, you want to add some attribute, you want to remove some attribute, you can go ahead and do that. Remember, when you are adding or removing attribute, you have to synchronously do that thing in the class definition, which is in the previous slide or to the previous code and this code. So the things should be in sync. So if you are out of sync, it will give an error. You're done here. Let's move on to the next slide. What is encapsulation? Now, after we are talking so much of the code and we have already plunged down inside the code, now we can talk about the encapsulation. With the introduction of objects, the concept of encapsulation evolves. So evolves, this is what I said. That means initially when the concepts was there, later the encapsulation or the data protection have been evolved over time. We are not going in the chronology of the evolve, how it evolved or what, but you know it is evolved. Encapsulation refers to the bundling of data and methods that operate on that data with a single unit. That is, single unit means a single instance, that is the object. Object is written here. Next, it helps in hiding the internal details of an object and exposing only what it is necessary. So that is the properties which I was talking about. The student's detail you cannot access until or unless you go through a proper method or proper channel, right? So that is called the protection or encapsulation of the data. Encapsulation in programming is like putting the data and the actions that work on that data inside a box, and that box is called an object. So now we are more on programming and lesser on the real world side. So I think the mental tussle is still going on your mind, but however the mist is demystifying slowly. The mist of the object oriented programming is demystifying slowly. It's like having a container where you keep things and only allow others to interact with them in a certain way. So that is the protection. This helps hiding the inside details, making it easier to understand the change how things work without affecting the outside. Encapsulation is useful for keeping code organized, making it more secure and allowing it for easier maintenance. So once you write in this fashion, right, the entire code will be very much interaction free. Say one class is defined and the entire data structure of that class, whatever data mining you are doing with that particular class, is completely secure. It is not vandalized easily. There is no kind of local global concept here. Everything is encapsulated inside that particular class and object, and that data is not at all vandalized by any other part of the code. So data is secure inside the code and throughout the code, and this way the encapsulation helps the more efficient use of mining the data. When you are mining lot of data in the object oriented fashion, maybe in some database, that is also very easy and secure to store and access that data. We are done talking about the encapsulation. Let us move on to the next slide. Encapsulation code example. Here we will talk about the encapsulation example code in Python 3. Here we start our code. This is our Python interpreter. And next we have the class bank account. Now you will see the much more in-depth programming example of the encapsulation. Although earlier examples are quite good enough to understand the encapsulation, but here we are again give a more thorough use of encapsulation. We have def, we have then init, then self, then account holder, then balance. So you can understand this is about a bank account and the class is bank account. So we are inside the bank. We have the object here. Definitely one customer is the object whose bank account we are dealing with. So account holder here will be the name and the balance will be the money. Here we write self.account and holder account holder. So this is called protected attribute. So you can see, so we have account holder and here we put a extra underscore. So this is called protected attribute. And here we have self, then double underscore, then balance, and we put balance. This is private attribute. This is much more detailed encapsulation we are going into. Earlier it was simple encapsulation. Now we are going towards a complex encapsulation. So this is called private attribute. We have double underscore here in the balance. And we have a method here, deposit self, then amount. So the customer can deposit money in the bank. So what will happen? The self double underscore balance plus equal to is amount. So amount will get added to the balance. Next, we have a print command, deposited amount of rupees in the new balance is self dot double underscore balance, then rupees. And next we have another method which is called withdraw. So a customer can withdraw money. So self and then amount. So we have here a condition if amount is less than self underscore underscore balance. So if requested amount is less than the balance that is remaining in the account, what will happen? That self dot underscore underscore balance is minus equal to amount. The amount it will get deducted from the balance. So for that balance should be greater than the amount requested. We print then withdraw amount of rupees, new balance is self dot underscore underscore balance rupees. Else, so in case the opposite happens, that either the amount is equal to the balance or amount is higher to that of the balance, what will happen? So it will print insufficient funds. Until or unless your bank account is a zero balance account, you will not have the privilege to withdraw all the amount. Generally, some amount has to be kept in the account in case it's a non-zero balance account. Now def get balance, then self. It will return the self dot underscore underscore balance. Let us go to the next slide. We continue the code here, creating an instance of the bank account class. Account equal to bank account holder name is Ram Ratan and balance is 5,000. What we do, accessing the protected and private attributes, we try to print account holder account dot underscore account holder, and then accessing the balance using the get balance method, account underscore get balance. Depositing and withdrawing money. First of all, we print the name and the balance. Next, access the deposit method and we deposit rupees 500 and we withdraw rupees 200. The following line would result in error because the balance is private. The next line here, if we try to print, right, the account balance, account dot underscore underscore balance. So if we try to do that, it will account an error, okay, since the data is private. Once you execute the code, this happens. First, we are using the account holder name. So name is coming here. You can see Ram Ratan here. And we are using a proper method, get balance. So we are getting the get balance. And deposited 500 rupees using this, and the new balance is 5,500 rupees. You can see after this has executed, this line is printed. Because this particular method has a print statement also. Now withdraw rupees 2,000, new balance is 5,300 rupees. This is coming after this line is executed. And here, once it try to execute, right, once we try to access a private variable, it gives an attribute error. Okay, bank account has no attribute, balance, it is private, so it is saying it do not have. And did you mean get balance? So it is proposing the method. So it is proposing the method rather than directly you are trying to get value. This way the encapsulation protects the data. Here we have seen a more tough example of the encapsulation. Through this example, you can download this example from the link provided in the description. From that link you will go to the GitHub and from there you can download the code. Here we are done. Let's move on to the next slide. What is inheritance? Now we'll talk about the inheritance. You are slowly plunging deep inside the object-oriented concept as well as examples. So what is inheritance? Inheritance in object-oriented programming is like passing down the traits from one thing to another. And that means a father has something, quality. The father can play a guitar. So the son also can play the guitar in case the father has handed over the knowledge. This is called inheritance. That means handing over something. It could be knowledge, it could be money, anything. That is called inheritance in real world. Now in programming, we will see the programming counterpart of the inheritance in object-oriented programming. Building on idea of classes, inheritance is introduced to promote code reuse and organization. So this is because code reuse. That means we don't have to define each and everything. If we have inherited from some other code, that will be used as is, and that would not have to be defined twice in the subcode, or here you will see the subclass. Inheritance allows a class to inherit properties and behaviors from another class, that is creating derived classes. It establishes the hierarchy where the subclass inherits the characteristics from superclass, fostering is-a relationship. This is the thing, that inheritance is coming from one to the another. Generally, there will be a superclass from which we define a subclass, and the subclass will inherit some of the qualities of the superclass, not all of the qualities. It depends upon the coding and what you are allowing to be inherited. The class that gives its trait is called parent or superclass, and the one which is receiving the traits or the attributes or the qualities is called the child or subclass. So it could be a parent class or superclass which is handing over some of the inheritance to the child or the subclass. This helps in reuse of the code and build on existing data structures. So the code reuse is nothing but something which you have written once can be reused without explicitly rewriting the code, and that is achieved by the inheritance in terms of the parent class and the child class, or the superclass and the subclass. This way code is reused. That means the methods, the attributes, anything whichever written can be reused in the object oriented programming. Creating an inherited class. Now let us see the code here. First line, class, then intern, then student. Earlier we have defined a class student, and here we are defining a subclass or child class which is called intern. The parent class or the superclass is student. Earlier we have defined student. Now intern. Let us see what are the changes here. Constructor of the child, def, init, self, then name, surname, role, company. Any student who may be doing some internship will be related to a company. So this is some additional info. The rest of the things will be inherited from the previous one. Next, super, then init, then name, surname, role. So you can see we are not writing this code again. Rather, we are inheriting from the super class. You can see super is here, then init, the name, surname, roll number. So it will go to the parent class and do all these kind of initiation of the attributes and come back to here. Next, only the thing extra we are having here is the self.company, and the company value will be, this attribute will be written here. Don't worry, all these codes are provided for download, and the download links are provided in the description, from where you can go to the GitHub, download the codes and do all the code experiments and modification, whatever you want. Or in case you want to just run and see the output, you can do that also. You don't have to write down, you can just download it. So here def display then self. So you can see the super.display calling the parent inherited method. Again, we are using the super attribute here to call the display which was defined earlier in the previous class or the parent class. Okay. We are directly calling that one using the super. The super is the keyword that actually helps to connect back to the parent class or the super class. And here we are using the print for the extra attribute, the company, and here we are writing self.company. And here def hail self, so that is a destructor, right? And destroy is invoked from intern.py. So we are saving this as intern.py. We are done here defining the inherited class. Now here in this slide we will be creating object of the inherited class. We have defined the inherited class, and now we'll instantiate an object or more than one object of that particular inherited class. So here starts our code. First line is hashbang user bin python 3. If namespace is main, then creating the object of the intern class. Intern obj is intern, then we write naga, then yamini 112 and stm. So this is the company name which is extra from the previous one. This student has got an internship in this particular company. We are giving it here. Displaying the initial details. So intern object dot display, if we write this right, it will print all these details which we have just given through the object creation. Modifying the details. Intern object, then set name, then ram. Okay, we are changing it, and then we write intern object that set surname is Prasad, set roll number is 114. So we are modifying all these things, and we are modifying the company also, Xilinx. So you can see this modification is happening similar to the previous example when we have used the object, not the class. So the class is handshaking one with the parent and the child class, or the super class and the subclass. They are handshaking in between to their internal methods to the super keyword, right? And when we use it as an object, we operate it in the very similar fashion that we have done earlier in the parent class. And here displaying the modified details, call the display method. So here the display method is called first time when all this data has been given as the input, and after this modification again this display has been invoked. Once we run this code, first we can see that this was the first set of data, and this is the modified set of data. So you can see that it has changed to this has changed to this, and this has changed to this, and also this has changed to this. So we can operate very easily in a very similar fashion. However, the attributes are dealt, or we are dealing the attributes in the very similar fashion of the parent class, same as the child class. But however, the parent child, the code reuse is happening through the super keyword. We are done here with the example. Please go ahead and download these codes and run at your end, and let us move on to the next slide. What is abstraction? Now we will go further and learn about the abstraction. This is another very important concept in the object-oriented programming, and let us start. Abstraction in programming is like simplifying models to represent complex things. So as I have said that object-oriented programming from by birth, it is designed to deal the complex object. But abstraction is something that will make much more simpler as part of the look. As classes and objects become more sophisticated, the concept of abstraction is introduced. So abstraction was needed. As I said, the object-oriented programming evolved over time. This abstraction is introduced to make things simpler. Abstraction involves simplifying complex systems by modifying classes based on their essential properties. Abstraction is nothing but here we have a complex data and we are redrawing the data with much more simple concepts or simple shape and size. The complex data we have and we are giving it a simple shape, that is called the abstraction. It allows developers to focus on relevant features while hiding the unnecessary or surplus details and complexities. That means you should be focused enough to deal with the problem and not the detailed data which is coming with the problem. So you'll find a solution for the problem and that will deal with the data which is related to the problem. This is called abstraction, and this is very programming related concept and you cannot just relate with the real world. So now we are going further deep diving inside the programming concept of the object oriented programming. So you should be very much aware how the object oriented programming concept begin and how it was formed. We have so far discussed, and now from this slide we are diving deep and you think in terms of the programming aspect to deal with the data complexity, because the data complexity does not visualizable in real world and the data complexity can be visualized only when you are writing the codes. So don't try to relate it. However, if you are able to correlate, it's good enough. In this programming concept is very much needed in object oriented programming. In simpler terms, abstraction helps us to understand things without getting into the vivid explicit details. Here, the main motto of the abstraction is to make complex set of data into a simple structural format and feed it into the object-oriented programming class and objects and all other aspects of the object-oriented programming. We are done here discussing about the abstraction, and let us move on to the next slide. Abstraction example. Here is the code example, the codes, and in the right hand side we will be explaining the codes. So the pink box contain the codes and the yellow box contain the explanation. First line is our Python interpreter. Next we have from ABC import ABC and abstract method. So ABC is a predefined module in Python and we are importing that. You know about this defining styles from the module in Python episode. And here we are giving the definition. ABC is a module in Python standard library that stands for abstract base classes. ABC is a shorter form of the abstract base classes. This is much more complex programming concept rather than the very easy things that we are correlating. And here we have defined a particular module of ABC. ABC is abstract base classes. It provides the ABC class which you can inherit from to create an abstract class. For abstraction, much more in a programming way, you can use this. So here goes our abstract class. We have the class shape and here we give it as ABC. So the ABC which we have imported will take care of this. And here we have defined @abstract method. So abstract method we have already imported here. @abstract method is a decorator that is used to declare abstract methods within the abstract classes. So we will define a method that will be very much abstract and that will not be very specific. Okay, let us see how. Def calculate area self. Okay, so self is the object constructor, right? So here we give the pass. So we are not writing anything and we are passing it. Pass is another keyword which passes of any definitions. Here you can see we have defined the prototype of the calculate area, but we have not written any code and we are using the pass statement to pass from here. In this case, the calculate area method is the shape class is marked as abstract. This shape is abstract now. This is the abstract class. Now, the calculate area method in the shape class is defined without any implementation using only the pass statements. We have not defined any methods to calculate the area. Let us see how we will do it later on. concrete class implementation of the abstract class. So now we are becoming specific from the abstract, and now here we are writing a class circle. Now the shape is a circle. Okay, now you can see this shape we are passing here, and this is a circle. New class is circle, and this is a specific class, not abstract class. Now def init self then radius, so we have to give the radius, right, of the circle, and we write self dot radius is radius, so that means we are attributing the numerical value as radius. This method is meant to be overridden by the concrete subclass. Now calculate area. Now we are making the abstract definition which was here in a specific manner for circle. What we are doing, it will return. Now the pass statement is not there, instead there is a return statement, and 3.14 into self dot radius into self dot radius, that is pi r square. Pi is 3.14 value, and the r square, that is the radius square, is self dot radius into self dot radius. So this gives the circle area, and the area will be in a square unit. So you can see we have defined the abstract class here, and then we are defining a specific class here, and here we are giving a specific area calculation in the method which was earlier an abstract method. So abstract method here we are defining with the abstract method keyword that we have imported. So this way the abstraction is created in the object oriented Python programming. We go further in the abstraction, right? Another concrete class is there. You can see the square, okay, and we give the shape which was the abstract class here, and we give the side length. So square have 4 sides and 4 equal length. Here we give the self del side length is side length, and here we are attributing the numerical value of the side. Then we have the def calculate area, and now we are having a specific definition instead of an abstract definition. Here return statement is there instead of pass, and here we write self dot side underscore length into self dot side underscore length. That means the length square, so that is the area of the square. The length of the side, we make it a square, it will give the area, and that is we are calculating using the calculate area. For circle it is having one type of area, and for square it is having another type of area, right? Now let us use this. We define a circle object as circle and radius equal to 5, and we write a square, then square side length equal to 4. And here we print area of the circle, and we will get the area here with this particular circle calculate then area. Okay, so using this method, okay, and similarly we will get the area of the square using this method. Once we execute this code, so you can see that this value which we provided is helping to get the area using this method, and the result is coming as the area of the circle is 78.5, and similar way the area of the square is calculating as 16. So please go ahead, download this code from the description. Once you click the link, you will go to GitHub, and from there you can download the code or copy the code. So here we are done for the abstraction example. You can see we can define an abstract class, and then we can define specific class. Complexities may grow more. Say if you are trying to define a rectangle area, right? In case you can add, you add it in the similar fashion and you calculate the area. So the complexity will grow. If you want to calculate the area of a cylinder, right, there will be 2 circular surfaces and there will be a cylindrical surface. So this way the thing can go on, the complexity can grow bigger, but the thing is that the abstraction is helping the complex thing to stay simpler. However, from object to object the complexity may grow high or grow less. The actual class, that is like square or circle or maybe rectangle or maybe cylinder, in that case you will have the specific complexity of that particular type of class. But in the abstract class everything is very simple. We are done here. Let's move on to the next slide. What is polymorphism? This is another good concept of object oriented programming. The polymorphism you should know in very attentive way. Polymorphism is the context of object-oriented programming, comes later in the evolutionary timeline. So it has came as the object-oriented programming evolved. It refers to the ability of objects to take on multiple forms of the ability of different classes to be treated as instances and of the same of the class through a common interface. This is called polymorphism. It allows us to use a common method name, but depending on the situation, it can do either different thing or the same thing in different way. So polymorphism is nothing but case to case, the object to object, one method maybe. Let us take an example. One method may behave differently. So that is called polymorphism. So we'll go for explicit codes, don't worry. Simply, it is a way that any method have ability to non-biological mutation capability. So why we are saying non-biological? Because when we talk about mutation, right, you will have the concept of biological mutation, but no, it is not a biological mutation. That is what I was saying. From one object to another object, it may have different kind of behaviors. Okay, so this is called polymorphism. So this is also there to accommodate the complexity of the object-oriented programming that is we are doing nowadays from the original object-oriented programming concept that was during its birth. These complexities got added, and now at present day we have all these concepts and to deal with the complexities of object-oriented programming. So this is nothing but a non-biological mutation capability of any of the method that is defined inside a class. Polymorphism example. Let us see an example here. And in the right hand side we will see the explanation. So the code will go here in the pink box and the explanation will go in the yellow box. First line is our Python interpreter. Next we have class animal, and then we define make sound. This is the kind of voice the animal will do. Okay, then we keep it as pass. So here we are not defining anything. We have a base class animal with a method make sound, which is marked with the pass statement, indicating that it is meant to be overridden by the subclasses. So in the subclass, what we do, we write a dog, which is a subclass of animal. Okay, and in that particular case, what we do, the make sound is correctly defined. We return oof, the dog sound oof, and that is then. For cat, which is a subclass of animal, we define the make sound as meow, and for a bird, which is a subclass of animal, we define the make sound as tweet. So the dog says woof, the cat says meow, and the bird says tweet. All these things you can see that the subclass, the particular method is overridden. That means it is dealing with the complexity, right? For each of the cases it will encounter. This is a very simple example, you can understand, right? The subclass dog, cat and bird inherit from the animal class and provide their own implementation of the make sound. So make sound cannot be defined at the beginning. In this real world case, if we define animal class, and the sound has to be modified in each of the subclass. We cannot make it here in the parent class. So the subclass we have to define it. The function animal sound takes an object of the animal as a parameter and calls the make sound method on the object. We continue here. The pink box will contain the code and yellow box will contain the explanation. Function demonstrating the polymorphism. So def animal sound, which we have just talked in the last slide. And here return animal.makeSound, creating instances of different classes. Dog, then dog, cat, then cat, bird, then bird. So you can see the class is here. It is, the first one is capital, the other two are small. So here it is small. So you can even name dog 1, dog 2, cat 1, cat 2 also you can do that. When we create the instances dog, cat and the bird and pass them to the animal sound function, polymorphism will come into play. So here we have defined the polymorphism of this function animal sound, and it will pass on to the make sound. So earlier we have defined the make sound for that, right? The appropriate make sound method of each of the object is called based on this actual type. So this selector part thing, that whatever there is a polymorphism, but it has to select the correct one, that is done through this programming using the common interface make sound with different objects. Okay, print animal sound, then dog, it outputs woof. Print animal sound, then cat, here it outputs meow. Animal sound, then bird, outputs tweet. Now have a careful look. These dog, cat and bird are objects and not classes. In classes we have defined each of their respective sound, and here since we are dealing with here this animal sound, right, it is actually helping the polymorphism, and this is polymorphism example. So you should take your time, spend time on this and understand this. This is different from the abstraction example that we have given earlier. Okay, here one particular decisive function is there which actually routes to the correct object and correct function. If you pass on that particular animal, right, here we are giving the animal as a class, right, and if you give that particular animal, it will call that particular animal sound. So you understand carefully code, maybe you spend some time with the code. This code is downloadable, and once you execute this code, you can see this first one give woof, the second one cat gives meow, and the bird gives tweet. So this is coming as the output. You can go ahead and download this code from the download link provided in the description. So you're done here. Let's move on to the next slide. Now here we do a specific comparison of object versus module. This might be good for you because when you are facing interviews, right, this kind of things may come, that what is the basic comparison, they say similarities and difference between the module and object. Start comparing here. Earlier you have learned the Python module in the last episode, and this episode you have learned the Python class and object, right? So let be there a side-by-side comparison. A module is a file containing Python code. It can define function, classes, variables, as well as runnable code. An object is an instance of a class. A class defines a blueprint of the object and specifying attributes and methods that the objects of the class will have. Now, this is the definition. We write the definition of this and definition of. First, we compare the two definitions. Module has a plain code and the Python class is a concept. So you can understand these two. Purpose. Now, let us see the difference and similarities of their purpose. Modules are used to organize code into reusable, manageable units. They help avoid naming conflicts, provide code encapsulation, and support code reuse. Objects are used to model and represent the real-world entities in a program. They provide a way to encapsulate the data and behavior into a single unit. So you can see that there is a bit similarity between the module and the class and object. However, these two are a bit different. Both are targeted toward the code reusability, but in different fashion. Object-oriented programming in Python can deal with a large and huge amount of complexity, but module, I think, is for the much more simpler kind of data handling. The object itself is by birth is to deal with the much more complex data. As you have come across all the concepts, all the 6-7 concepts that coexist together in object-oriented programming, now you can be able to correlate and differentiate the module and the class. We are done in this slide. Let's move on to the next slide to see some more comparison. Here now we compare for the organization. Module provide a way to organize and structure your code. Class and objects allow you to organize the data and behavior within your program. It's just about the code and it's about the data that the code is dealing with. The class and object is about dealing with complex data and the concept. The module is just for the code, the reuse and structure of the code, the segregation of the code and the encapsulation of the code. So module does that, but Python class is having a much more higher capability. Scope. Modules provide a global scope for function, classes, and variable. Objects, on the other hand, they have their own scope and encapsulate the data behavior within the scope. So this is a strong data protection. You can see that the module, if it is instantiated, it can have either global or local scope, but the object and class, the data is much more secured and it is handled in a much more strict manner. Instantiation. Modules are not instantiated. They are typically imported as a whole. That means we do not have an instance of a module, rather it is imported. That means it is taken as a copy. Objects, on the other hand, are instances of the classes and must be instantiated using the class constructors. There is a fundamental difference of calling the module and calling the class. Calling the class is object, where we instantiate the object, and with the object all the set of data and methods are instantiated. But for module, it's just about code. So even we do not bother that module could be a procedure oriented code, but object oriented code, there could be mixture of both. Some of the methods may contain the procedure oriented code inside the object oriented code, and it's a very complex structure as compared to the modules. Modules are used to organize and group related code. So module are for code organization and code use, simple as that. So it can be for even procedure oriented, but objects are used for model and represent individual entities with specific characteristics and behavior. So the usage of object and class is much more targeted, rather than module is much more generic. Module is a very generic concept and object and class is much more specific concept. Module can deal with simple amount of data, but the object and the class, they can, that is the object oriented programming, can deal with a huge large complexity in terms of abstraction, in terms of polymorphism, and all the concept that can coexist together inside the object oriented programming. So here we are done comparing object and module side by side, or class and module. Okay, so here I may write class or object, but however class or object means that one is the definition, another is instantiation, so please don't get confused. So we are done here. Let's move on to the next slide. Summary. Let us summarize in this slide and the upcoming slide about whatever we have learned so far, so that the entire concept is now jotted down into your mind. Class. In Python, when you declare a class, you are instructing Python to create a blueprint of a new kind of object. The object and the class will contain set of data that is called attributes, and also some methods which will be used either to write or read those data or do some modifications to the data. Object. This term in Python has dual meanings. It can refer to the most fundamental type of entity, and it can also denote any instance of the particular type of class. So this is a fundamental type of entity, because Python from birth is a object oriented programming. Its structure from the beginning is object oriented. Hence the object is a very fundamental entity in Python. After you learn the object oriented concept in Python, then you look back to the Python codes you have done so far, and you will see the small touch of the object oriented programming there. The dot operator, I give you a hint, and rest of the things you can find out yourself. Instance. When you use a class to tell the Python to create object, the resulting object is called instance of that particular class. Instance. These are terminologies. We are making familiar with the terminology. So object and instance means that we have instantiated the class in an object. So these are coexisting concepts. Def. In Python, def is used to define a function, especially when you are doing so with the context of a class. Self. Inside functions within a class, self acts as a variable representing the instance of the object currently being accessed or manipulated. So def is defined for a function or a method, and self is the object constructor we have come across. Inheritance. This is the concept that a class can acquire characteristics or traits from another class similar to the individual inherits from their parents. So this is the things we have learned. Now let us go to the next slide of the summary to get much more details of the concepts. Composition. The concept revolve around the idea class can be constructed or composed using other classes as component, resembling how a complex object like a car can be built using individual parts like wheels. So this is called composition. We have not given any example of this, but the object-oriented programming does have this concept. Attribute. Attribute in Python classes are properties that arises from the composition, often taking form of variable associated with the class. And in real world, the attribute to a person or a student, maybe it's hair color, maybe it's eye color or skin color, like that thing attribute. So in the similar way, attributes in the Python objects are nothing but variables containing different values or different properties, which are also known as attributes. Is a. The phrase is used to express that one thing is subtype of or inherit from another. It is saying a hilsa is a fish. The fish is a class and hilsa is an object. So is a concept is connecting an object with its class. Has a. The phrase indicates something is composed or processes from other traits. Say Hilsa has a fin. So the attribute getting connected with its object using a has a. So attributes are connected through has a, and the object and its class is connected using is a. So these are the concepts you may find in text, in maybe you are reading a book or something like that, or you are maybe reading an article in the internet. Here you can find all these concepts. Or in your company you may have some code with some comments which are using these words. So that's why we have summarized all the things that we have learned in today's episode. We are done here. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.